What the one you really need to remember, e to the x, what's that?
E to the x is 1 plus
1 over x over 1 factorial plus x squared over plus x cubed over...
Basically, it's
No,
x
no,
to the
no.
n over...
X to the n over n factorial, yes, correct. So therefore, sine x, what kind of function is that?
It's odd.
It's odd. So sine x is going to be what? X over 1 factorial minus x cubed over plus x to the 5th over 5 factorial minus x to the 7th over, not 6, 7 factorial, yep. And then you know cosine is?
Cosine is 1
Even. Yeah. So I'm just writing it out. So you know cosine x is going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over. And you can remember that also because the derivative of sine is cosine. That's just another way to remember it. Exactly. Okay. Yeah. In sine of x squared, what's that going to be? It's going to be x squared over 1 factorial minus, minus x to the what? 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. And then the other part of it is just cosine, right? So what are you adding together? You're taking this, and you're taking this, and you are adding them. And you end up with, you got to do it out carefully, so you know that sine of x squared plus cosine x is going to equal, what do we got here? How many? We got 1, right? But then what happens? We get 1. You get minus, so you get x minus x, so minus x squared over 2 factorial, right? But then you have plus x squared over 1 factorial, right? I'm adding them.
X squared over 1 factorial before that. So 1 plus x squared over 1 factorial. Then we keep the pluses and minuses.
Oh, you want to do that way? That's fine. Okay, that's fine. So you're going to do, I see what you're saying. Plus x squared over 1 factorial, like this, right? And then you're going to have minus x squared over 2 factorial. And then minus x to the 6th over 3 factorial. So what have we taken care of so far? For me, it's always just keeping track of what I've taken care of. Those and those. And then, we missed one, didn't we? If we want to keep it in order, what do we have to... I understand you want to make it plus minus, but it would be nice if we kept the powers in order. They're going to want you to write it that way. What did we miss? The 4th power right there. So we had to plug in x to the 4th over 4 factorial. So we've done 5 terms so far. Are we okay so far? But we need to simplify it. Do we need to simplify a little bit? Should we simplify a little bit? The order of terms should be increased. We're not done yet. Taylor series needs to be you need to write it in increasing order of power. We had forgotten x to the 4th, so we need to actually put it in there. Are we okay? Do you understand that? Yeah, we're not done yet because we have to actually combine these two terms right here. So what's that going to be? 1 minus what? X squared over? No, just, well, 2 factorial. It's 2 factorial because you get x squared over 1. So it's x squared minus half of x squared is x squared over, which is the same thing again as what? It's kind of cool. Anyway, so then what's the next term? X to the 4th over 4 factorial minus x to the 6th over, because there's no other, there was another x to the 6th, wasn't there? There's an x to the 6th up there. So we can actually leave this off, because it just asks for the first 3 terms, right? Does it ask for the first 3?
It asks for the...
So what do we need to actually do here then? If we're going to do the first 4 terms, we have minus x to the 3rd over 6. We have minus x to the 6th over 6 factorial. So these two right here need to be glued together.
Don't we need to do the third and 4th terms in the...
What? Okay, here's the deal. When we figure out the sum of these two things, you add them together first, put everything in order, and then pick the first terms. It goes in ascending order of power. Why is it weird? We're adding like terms together. I don't understand why that's weird.
It just doesn't seem to be answering the question.
The question, look, you guys are looking at the different things here. Look, it's one of them minus a half of it. So it's still positive. So it equals positive. You're absolutely right. That is a mistake right there. You're absolutely correct. Okay, this is correct, this is correct, this is correct. If we want the fourth term, is there an x to the fifth term in here? No. So what is the next term?
No.
There is no x to the fifth.
I was looking at the no.
Is there an x to the sixth term?
Yes.
Yes, the x to the sixth term is going to be plus, what do we have here? You're going to add together x to the 6 over, sorry, negative x to the 6 over 3 factorial minus x to the 6th over 6 factorial. So you need to combine those two. You're just adding fractions together. Okay, so what's this going to come out to be? Negative, right?
Yes.
Or is it, it's all negative, right?
Yes.
So it's going to be negative what?
Negative 121.
Over x to the 6th, right? Does this make sense? So this right here is the first 4 terms. Are you okay with it, McFall? No. General Taylor polynomial for the x to the 6th term. So basically, if you had x to the 6th right here in the general Taylor polynomial, what's the coefficient of that? It's f6 evaluated at 0 over what? Over 6 factorial, correct? In the general Taylor polynomial, it tells you that the coefficient of x to the 6th is this, correct? But look what we have right here. What is the coefficient of x to the 6th? What is 720? So therefore, what is f6 at 0 going to be equal to? Done. It's a 1-point question. This right here is how far off what is from what? How far off the fourth sum is from the actual value, right? So how do you prove it's less than 1 over 3,000? What do you find? Not well. P4 is the sum. Okay. So what do we need to find? The fourth. Not the fourth entry. We need to find the fifth entry. The fifth entry of this thing evaluated at what? 1/4. So we need to find. Oh, the graph of it's right there. So we need to find this right here. So we need to find f of 5 of x, right? Then
Over 5.
yes, because the term is going to be, it's over 5 factorial. That's correct. So look, let me get back to this right here. Okay. So we know that if we look at the graph, did I paste the graph in here? I did not. Not in here. Sorry. Here's the graph. This is the graph. It tells you right here. Based on this graph right here, we know the next term in the Taylor polynomial, we're looking at f5 evaluated at 1/4 all over 5 factorial. This right here is going to be the what? The error bound, right? The error bound, exactly. So if we actually look at that, let's look at 1/4 right here. What's the maximum it can be? This is 1/4 right here. We know that that value, what is that value definitely less than? Is less than 40, right? So you know this right here has to be less than or equal to 40 over what? 5 factorial. What is 5 factorial? That's 40 over 120. And what's our error bound supposed to be? Oh, I'm sorry. There's a we forgot something here. What are we missing right here? That's the fifth. Yeah, we're missing a major component. Sorry, to the fifth. So what do we put? Yeah, little bit. I was like, that's actually a terrible error bound. This should be 1/4 to the fifth. That is the fifth term in the Taylor polynomial, right? And what do we times what? 1/4 to the fifth. So it makes this thing actually doable. So if you do this out, if you did it out, it comes out to be 1/3072, which you know is less than 1/300. There you go. So hey, they gave you. Oh, I chopped it off, but they gave you e to the x. Would they always be nice enough to do that? No. That's a gift. So what can you tell me about e to the negative x? Not e to the x minus 1 squared. What's the only thing you need to do? Just substitute. Yeah. So 1 plus x minus 1 squared. plus what?
X minus 1 to the 4th over 2.
Over 2 factorial plus what?
X minus 1
To the
6th.
6th? You sure?
True to the
No, I agree with you. I'm just checking. Those are the first 4 non-zero terms. Is that correct? And it's about 1. It's not centered at 0. It's about 1. So is this a Maclaurin? No, Taylor. Good. Here's the thing. What did it define f as?
Oh, wow.
What is f of x? It tells f is the function you're dealing with, right?
E to the x minus 1 squared.
The whole thing minus 1 all over what?
X minus 1 squared.
So you know this right here, this right here, is that. So you subtract 1, what goes away? The 1. And then you divide every single term by what? X minus 1 squared. So what does it turn into? 1 plus x minus 1 squared over... No, we created a new one because it's this over x minus 1 squared. Every one of these terms gets divided by x minus 1 squared. You subtract 1 first, and that gets rid of the 1. But what's x minus 1 squared over x minus 1?
That makes sense.
I'll make it clear. I don't know, but I'm going to put it in there just so we can have it. X minus 1 squared over x minus 1 squared plus x minus 1 to the 4th over x minus 1 squared 2 factorial plus x minus 1 to the 6th x minus 1 squared 3 factorial. And what would the next one be?
Wouldn't just the first one be 0?
First one be 0. 0? It's the first 4 non-zero terms, so we're dropping it.
Oh, the first 4 non-zero.
Here's an infinite number of 0 terms. It's okay. 4 factorial. It's okay. It's okay. So what does this turn into? They're going to want to have it as 1 plus x minus 1 squared over 2 factorial plus x minus 1 to the 4th over 3 factorial plus x minus 1 to the
6.
over. And are you done? No, they want the general term, right? What? It's subtracted. They killed the initial one right there. We killed it, but then we made a new one. Because we divided x minus 1 squared by x minus 1 squared. It's asking for the general term. So that's asking for the summation notation. So what's it going to be? And let's go from n equals 1. Or do you want to go from 0?
Yeah,
0, 1, 2. What do you want to do? Let's go from 0. Sure.
okay.
To infinity. What is it going to be? X minus 1 to the what power? N? All over what?
All over
N factorial. Right. Close.
but it doesn't quite.
It's close. It's almost there. The n factorial works, right? And the x minus 1 is there, but it goes 1 then 2.
Factorial doesn't exactly work for later.
Okay, why not? This is over 1 factorial, 2 factorial. So the n factorial does work, but the power doesn't. It goes 1, 2, 4. It goes 0, 1, 0, 2, 4, 6, 8. Those are all what numbers? 2n. So this needs to go away and make it 2n. When you plug in 0, what do you get? You get 1 over 1, which is 1. Because the definition of 0 factorial is 1. What is it?
One problem.
What's the one problem?
It has to be n plus 1 factorial, or it has to be the 2n. It has to be a 2n minus 2.
Why? Oh, I see what you're saying. Because if you plug in 0, what is 0 factorial?
0 factorial. Yeah, it works for the first term, but not for the second.
Ah, yes, because it's 0 then 1. Oh, I see what you're saying. So this one is a 2. I totally see what you're saying. So what should we start off with instead? Let's just start with 1, and then what do we change this to?
N
Minus 1 factorial.
no. That one should still be n factorial. The one on top should be.
Oh, I subtracted 1 from the wrong place. You're absolutely right. So this is n factorial still because it goes 1, 2, 3, 4 on the bottom, right? But then on the top, what should it be? 2n plus 2? You sure? Isn't it 2n minus 2? It's 2n minus 2.
2 times.
Yeah.
Yeah,
2 times n minus 1. Okay. Does that work? Plug in 0, yep. Plug in 1, yep. Plug in 2, well, you started at 1. Plug in 3, yeah, it works. Cool. There's your general term. Nice. So, or, let's just write both of them down here. Or, what was the other one? N equals 0 to infinity of x minus 1 to the 2n all over plus 1 factorial. There's another way. Either way is fine. Either way works. So what's the next out? You're looking at the limit as n goes to 0, n to infinity, sorry, of, what was it? Is it the n plus 1 on top or the bottom?
n plus 1 on top.
So x minus 1 to the 2 times
N plus 1.
minus 2 all over n plus 1 all over x. Well, actually, you know what? I'm just going to multiply it out. Times n factorial over x minus 1 to the 2n minus 2, right? So what do you end up with? This is gone, leaving you with that goes away, right? Correct? And then you're subtracting, you end up subtract, the 2n cancels with this 2n, right?
Yeah, the 2n cancels with that 2n.
So look, what is this right here? What is 2 times n plus 1 minus 2? That's 2n plus 2 minus 2, right?
Yeah,
Which is 2n. So this turns into what? It's x minus 1 to the what power? To the what? To the 2, right, exactly. Over what? And it's as n goes to infinity. X is fixed, so you can always get to a point where n is greater than x, so it's going to go to 0. And you know that that is always less than 1. So always what?
Always
Convergent. So the domain, the interval, so the interval, it asks you for what the interval of convergence is. What would you say the interval of convergence is? Well, you could say it's r, or better yet, negative infinity, infinity. That's an interval right there. If it asks you for the domain, you would say the domain is all real numbers, r. So what do we know f is? We know f, our approximation for f, what was it? You got to go back up and get it, right? Because where is it? Where is it? Where is it? There it is, right there, correct?
Yeah, the one in the green box.
Well, I'll just write this out. Is that okay? And try to do it better than that, apparently. This. Is that okay?
Yeah.
That is f, correct?
Yes.
Okay. So we had that because it gave it, well, we figured it out, right?
They
They
didn't give it to
didn't give it to us, correct? Okay. So we have this. So if we actually want to do the first derivative, we need to do the first derivative of each of them. So f prime of x, what's that going to be? Well, the first thing folds. 2 cancels. What are you left with?
Can we not take the derivative of the sum?
Oh, you just want to do the general one? You know what? We can, but let's just do it this way, okay? Let's just do it this way. So what do you end up with? X minus 1 over 1. Then you drop the 4 plus what?
Plus
4 times x minus 1 to the third over what? Over 3 factorial plus 6 times x minus 1 to the what? Over 4 factorial. And it keeps going, right? So then if you do the second derivative of this, what do you end up with? 1 plus 4 times x minus 1 squared over 2 factorial, right? Because the 3 cancels with 3. Plus 6 times 5 times x minus 1 to the what? All over 4 factorial. And you keep it like this. Now here's the thing. You're looking at that and you're saying, okay, inflection points, where does it change sign? Where does the second derivative change sign? Can you answer that question for me? When x equals 0? Nope. Nope. It's x values we're looking for. Tell me the x values where that changes sign. None. Look at it. What do you know about even powers, everybody?
they're always positive.
All of our coefficients, right? All of this are all what? These are all already what?
Positive.
These are all positive already, right? This, it's always going to be x. It's going to be x minus 1 to the 6th in the next one, right? These are all what? Positive. So what do we now know? F double prime of x is always going to be greater than or equal to what? Well, 1, because you could plug 1 in and it's 0, right? But it's still greater, which is greater than what? 0. So this is always what?
Always
Concave up. So no inflection points. None of them. None, 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 none. Very cool. It says write the first 3 non-zero terms and the general term for the series for cosine x about 0, x equals 0. Okay, you just did the first 3, and it wants the general, right? So what's the general going to be? You can actually write it in the same line. You can do this da 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 plus. What's the general one going to be? X to the
well, x to the 2n times negative 1 to the
times negative 1
n.
to the n, right? All over what?
2n factorial.
Yeah. Good job. You could write it out like that, and you would get the 2 points. So we need to keep going. So that was 2 points, so we need 2 more. So we're doing f. What do you do to this series to make f? What do you do to it? You subtract 1 and divide by x squared. So you subtract 1 and divide by x squared. So you end up with f of x is equal to, we're going to subtract 1. That kills the 1. We divide by x squared. So what are you left with as your first term? Negative 1 over 2 factorial plus x squared over 4 factorial plus x to the 6th minus, thank you, minus x to the 4th over 6 factorial, right? It's going to be 2 greater, plus, what does it become? X to the 2n minus 2, negative 1 is still there to the n all over. 2n what? Factorial.
Negative 1 to the n minus 1.
To the n minus, yeah, because the sign, you're right. You're right.
Plus 1 or any odd number.
Does that make sense? Is that good? How did we use the Taylor series for f, found in part A, to determine whether f has a relative maximum, minimum, or neither at x equals 0? How can you check a function to find out if it's a relative min, max, or neither at a specific x value? That's which derivative? Oh, get better than that. Come on. You can do the first derivative test. You can also do the
Second derivative.
yes. If you do the second derivative test,
You just have to prove that the first derivative is 0.
yes, you do. Yes, you do, of course. But if you have the second derivative, which we do have, why do we have the second derivative? It's part of the Taylor polynomial, right?
It's just the negative value.
Correct. Okay, so here's our f right here. You see this? Everybody? You got that? There's our f. So what is f prime going to be? F prime of 0? Do we know what that is? And we need to know what f double prime of 0 is. F prime of 0, if we do the derivative, what do we think it comes out to be?
Not too bad.
And let's ask this, for example. I have a question for you. F prime of 0 times, in the Taylor polynomial, where is f prime of 0 in terms of the coefficient? It's the coefficient of x to the what power? X to the what power?
X to the
Do you remember?
first.
Thing. Let's look at our expansion of f. What is the coefficient of x to the first power? Does x to the first exist in there? So what is f prime of 0 equal to? 0. So we verified the first part of what you wanted, which is fine. But we now need f double prime, right? F, the second derivative at 0 over 2 factorial, has to be the coefficient of what? The x squared, right? So let's look here. 1 over 4. Now that's one question I have here. Is it going to be 1 over 4 factorial? We should be careful here. Yeah. F double prime Taylor series. Yeah. Excellent. So hold on. We have to be careful here. So what is the coefficient there? 1 over 4 factorial. So we know that f to 0 over 2 factorial has to equal 1 over what? Don't move. 4 factorial. What does that tell you? What does that tell you about this? It tells you that f2 of 0 is equal to 2 over what? 24, which is 1/12, which is positive. So therefore, f double prime of 0 is greater than 0. So it's going to be concave what? Up. So what is it? Relative min. Okay. Your homework.